Now, so let me introduce about JSX and how we create these kind of games. As you can see, this is a screenshot of an iPhone, and the game, well, it's a pretty complicated game, but it's actually running on a web browser, and we are creating such games. So today I'd like to talk about JSX, which we use to create such games, and JSX is a statically typed programming language. And also, I'd like to talk about how we bind the W3C standards to JSX. And regarding other aspects of the game, Task-chan, who is my colleague, will be giving an LT later on, so if you could listen to him, then that would be great. So let me introduce about myself. My name is Kazuho Oku, and actually I started as a web browser developer called, the browser's name is called Palmscape, which was the earliest web browser for the Palm OS. And then I moved to another company and started doing web-related development. And now I'm working for DeNA. And DeNA, Thomas-san has introduced my company, thanks to him. But it's one of the largest mobile gaming platform companies in Japan. And the other, as you may know, is Greedy. And thank you for them for hosting this event. So, to write large-scale games using JavaScript, we are facing problems. And one of the problems is that the code size is becoming larger and larger. A great example of such application is Kington, which is developed by Cybos, actually, it's my previous company. And it contains more than 10,000 lines of code in JavaScript. And similar cases exist with social games as well. So that even the JavaScript code gets modified. It's still about 5 megabytes of code, and it's been developed by more than tens of developers. So it's becoming very hard to maintain. Of course, there are good parts in JavaScript. And for example, it's a very clear language, and it runs very efficiently. And, well, it's also very primitive and easy to extend as well. But there are not so good parts as well. And the largest problem is that, for us, it's so low in productivity, because it is very difficult to find bugs, so that it takes a lot of time to do the debugging. And it is also slow. Well, it's very fast, or faster than before, but it's not as fast as native code yet. And also, it consumes a lot of memory. And it's not a problem for ordinary PCs, but for mobile devices, the memory constraint is very severe, so it's a big problem. And also, the slow startup has been a problem as the size of the JavaScript code is increasing. And to us, it seems that the reasons why JavaScript is becoming harder for us is that it's a dynamic language. So all the error checks are done at runtime, so it's very hard to detect them before running them. And also, the adaptive compilation makes the startup slower and consuming much more memory. And it is also difficult to apply heavy compiler optimizations. So our solution was to develop our own dialect of JavaScript, which enforces static types to the programming language, and do optimizations during the translation to JavaScript. And so that's why we invented JSX. And as I said, the goal of JSX is to create an excellent programming language for the web developers, so that it will run faster, and also it will provide higher productivity than JavaScript. So the design principles, these are the ones we took. And JSX is a fully statically typed language. There are other approaches like TypeScript or Dart by Microsoft and Google, for example, but they are partially statically typed languages. On the other hand, JSX is a fully statically typed language. And by using type information, we detect errors at compile time And also we do optimizing compilation so that the compiled code would run faster than if you write directly using JavaScript. And to ease the migration of our developers using JavaScript, we provide expressions and statements mostly similar to JavaScript. And we provide a class-based OO. So this is a code snippet of JSX. And as you can see, it's a very simple Java-like class definition. And at the statement level, it's very similar to JavaScript. And as you can see, you could do function overloading, which in JavaScript is often misused. And actually using the arguments object in JavaScript, it causes lots of GCs and performance drawbacks. So we wanted to get rid of those problems. So we use function overloading. And regarding type conversions, we have a as expression that converts this .x, which is the number, to string. So if you're familiar to Java or JavaScript, then it will be very easy to start developing in JSX. And here are some numbers, performance numbers regarding execution speed. And as you can see, for example, Box2D runs from 12% to 29% on when ported to JSX, the JavaScript. And in case of Whalebench, it runs more than 60% faster on iOS. So you can see that our optimizing compiler does have some significant efficiency. And the other problem, the code footprint. As you can see, if we use JSX, then we can use the type information to do more minification than other minifiers running at the JavaScript level. So if you use Uglify.js or SMangle, which are the current state of compressors, you get like 80% of compression ratio. While if you use the JSX minifier, then you get like 40% of the original code. So the minification works pretty well if you have type information as well. And so these are the screenshots from our JSX development, and this is a source level debugging on Google Chrome. And we also provide experimental support for automatic completion, so that using the type information, you can, for example, doc.id or the memo functions like create element and document are suggested, so that it will be much easier to develop. We also have an integrated testing framework. We also have a profiler, so that you could profile any games running on iOS or Android. And this is a list of our supported optimization method. And by using such optimization methods, for example, source code like this in JSX is compiled to something like this in JavaScript. So for large-scale games, you never want to write these kind of codes because it's so messy. But so using JSX instead to write structured code, and then using a compiler to transcode the source code to JavaScript is actually a good approach. And so let me go to my next theme, which is about binding JSX to the W3C standards. And well, we need to translate W3C IDL to JSX, since we want to help developers writing web applications. And by doing the translation, we could detect type errors such as document create element where E is missing, or we could use the type information to detect logical errors as well. So this is actually the interface definition in JSX. And these kind of interface definitions are being translated using a Perl script from W3C's IDL to JSX interface code. So we are currently translating 35 IDLs with 358 classes in total, mostly taken from W3C org specs, and others from such vendors as Kronos or browser vendors. And the lessons we learned from doing such translations is that, well, they are union types, many union types in the spec. And unfortunately, we didn't investigate the ideas very deeply before we started developing JSX, and so JSX doesn't have a disjoint type, so we use variant. And the other problem is that some types are not narrow in the ideal. For example, as I talk about the HTML optional element. And the other thing is that due to the limitation from JavaScript, some interface definitions are lost when translating, when browser vendors create their bindings on the web browser. And that's unfortunate, but that's unavoidable. And the other problem is that, well, some ideas on the working graph has errors, syntax errors, so we are not supporting all of them, but we are supporting most of them because our developers want to. And the conclusion is that it is possible, it is actually possible to use a statically typed language to do web development so that you could have better productivity and execution speed and other merits. And I'd like to thank you the W3C members for providing a wonderful ideas so that we could actually translate the interface to our statically typed language. Let me express my thank you for them. And this is all for my presentation. So if you have more interest in JSX, please visit this website. Thank you.